Alright, Crewton Ramone, doing some third power algebra. This was actually a 2-hour session with some little boys aged 10 to 12. One of the kids was a pro. He's had many lessons, and the other two it was their first time. So I forgot to take the camera out with all the stuff that we did. We started off just getting to know the pieces, went over the 5 basic concepts, learned how to add numbers together very quickly, did multiplication very quickly, and then we started fooling around with this because the one boy had been there enough times that all the things that we do to the other two kids was old hat to him, and so that he would get some value out of it, and so that the students would get some value out of it and see how fun and easy the math can be. We went right into third power algebra. So within 1 hour, these kids that were novices were doing stuff that this kid that had been there quite a few times also found new and interesting and maybe a little bit challenging. Let's see here. So, I apologize for the grainy shot. It was interesting light. We've had strange weather here in Hawaii. Anyway, the floor is a fun place to build. And so what we did here is start fooling around, and even though they're on this side, these are x to the thirds, these are some x to the seconds, and so forth. And I just told them, build whatever you want. Build some stuff on the floor. After we had fooled around and drew some pictures, and we did some discovery, you can see other screencasts where we identified all the pieces and talked about what 1 in 10,000 is, and we actually went up to billions and trillions because we kept changing the scale because they were very interested in what would happen if this was a 10,000 or if this was a higher power and so forth, because they were amazed to see that we could show x to the third or 1,000 in 2 dimensions instead of making it a cube. And there's a huge long one. See, bigger is just funner. I'm telling you, little kids, and these are kids actually aren't that little, but they're this one's 10, and this one is 12. And playing on the floor and building these things is fun because you get to see just exactly how big it is and why it's great to use symbols and drawings. Because if you were trying to model all of these problems, it would take you forever. But it's fun at first to draw them out, or get a hands-on spatial experience of it, and then later draw them out, and then later just go directly to symbols. So there it is. I try to get the whole thing in a shot. They're building up the top right there, and then here's another student, another one, 3 of them. He's building one where he doesn't make it quite so long because he's got a little slightly more confined space. And here, they're finishing off the top of that really long one. And there it is, right? We didn't put little green units in there, but we know, see, and this is good for the 10-year-old, if it's 2 this way and 5 this way, how many's in there? And then later on we get bigger and bigger and change them around, but we start understanding factoring and understanding the concept of the rectangle. And if I know the 2 sides, I've got multiplication, and if I know one side and the whole thing, I've got division, and so on. So the concepts get cemented. And here, the child had to do some addition, which he still needs work on, and multiplication combined in order to count up everything that was going on there. And so here they decide to get all the pieces together and build one huge one. Right? Like I said, bigger is just funner, and they had a good time. We went over by like almost a half an hour. It was a 2.5-hour session. It was supposed to only be 2 hours. But when they're interested and enthusiastic, probably not such a good idea to stop while they're right in the middle of it, right? I mean, always leave them wanting more, but, don't give them completion anxiety. So here they are putting a whole bunch of those guys on the side, and there is the finished product on the floor there. Look how big that is. You have to count all these guys out and count all these guys out. Took the 10-year-old quite a while to count out all of this. And then all the units, or excuse me, all the X and the units that would fit in there, they decided to only put 1 across over here, so it was really easy. This is 7 across right here, by the way. So there's, just right here, there's 14x to the second. And let's see, did I get some pictures of the drawing? There we go, close up of the top there. Alright, so, oops, I got a little edit there. There's the picture of the top. I was seeing if I took any pictures of their notation and symbols and drawings in their notebooks, and it turns out I did not. So, I have to put some things, put some symbols to these pictures a little later, or as if I'll ever get around to it. But anyway, the idea being is that here, in playing on the ground, they actually get the hands-on experience, third power algebra, and all we're doing, we start counting up what we've got here. So they can see this is 1, 2, 3, 4 x to the third. And if I'm going to make a rectangle out of it, I can't just have an x here and an x there and an x there. I'd have to have another x to make it fit, and so on. And that I could take this and perhaps I could reshape it and make it just an x across and so forth. But just playing with them, I mean literally playing with them, getting your hands on it, and then counting and identifying it. That's all we're doing. Patterning, getting used to the concepts. For the youngest child in the group, it was basically multiplication and addition exercises. For the older kids, it was a little bit more of algebra and factoring and seeing what happens when you put the manipulatives together in certain ways. But they were doing it. I wasn't telling them, all right, I want you to make this 2x plus 3 across, or 2x plus 2 across, and 2x squared plus x plus 1 up, or whatever. I just didn't. What we did after they got done, and we had a little exercise where they did 6 drawings, and you can see that in another blog post, where they could draw whatever they wanted, and then they had to tell me the sides and see if my drawing came out to be their drawing. And then so forth. They played among each other, where they told each other the factors, and then by drawing the factors, they came up with the whole rectangle. In other words, if I had one side was, let's take a look at what I got here, like this one. If I told you that one side was 2x plus 1, and the across is 2x plus 1, and the up is x to the second x plus 2, could you tell me what the whole rectangle should look like? And so they got to play with that. Anyway, we just had fun on the first day, getting used to the pieces, playing around. We were going to get to some fractions, but we never got around to that. But the idea was to have a good time and include everyone, the veteran and the novice, the older kids and the younger kid, so that everybody had a good time. And see, you can see if you're homeschooling, all of your children can participate. If you're in a public school situation where you have a classroom of learners where some are, quote unquote, slower than others, then, all of them, this levels the playing field for everybody, so that they can all learn and have a good time and hopefully develop some enthusiasm and interest in the mathematics, because now, the basic abilities they need are the ability to count to 9, right, and identify a rectangle. That's it. Have fun. Tell us something same or different or not. They speak English, we can teach them math. It's as simple as that. So, you can use this in a variety of situations with a variety of students, sped kids, whatever, gifted and talented, put them all in the same group and watch what happens. Amazing things can happen when you put kids together and they all have a fun time and you get the group learning experience going on. Go to Crewton Ramone's House of Math.com. There's a couple of videos. In fact, I think there's a TED Talk on this also, posted at my website and also on the blog. Anyhow, Crewton Ramone's House of Math.com for more.